Jai Hind all of you. Today we will discuss numericals on average and RMS values. In the previous lecture we have discussed how to calculate average value and RMS value of an AC quantity. So theoretically we have discussed method of calculation of average and RMS values, and we have explained two methods of calculating average and RMS values. The first method was graphical methods, in which when the value of AC quantity is known in small intervals of time, that is the value of AC quantity is constant during very small intervals of time, then we use the graphical method for calculation of the average and RMS values. And when it is not exact value of AC quantity is not known in the exact value of the AC quantity is not constant and unknown in small intervals of time, then we use the analytical method for calculation of the average and RMS value. For example, in case of sine waves or output waveform of half wave rectifier, output waveform of full wave rectifier, for calculation of average and RMS values of these waveforms, we use the analytical method. And when the value of AC quantity is known or constant in very small interval of time, then we use the graphical method for calculation of average and RMS value. So let us take the example. First example we are taking, and this example is an alternating current of frequency 60 Hertz has maximum value of 12 ampere. Write down the equation of instantaneous value. Find the value of current after 1/360 second, and third part is time taken to reach 9.6 ampere for the first time. So we will so here is the solution of this question. How to solve this? Given that frequency is 60 Hertz and maximum value and it is current, so IM is 12 ampere, then we have to write the equation of instantaneous value. First part, we know that general equation of an AC quantity, it is given by small I is equal to Im sin omega t. Now in the question Im is given and we have to find out omega. What is omega? It is angular frequency in radian per second. So how to calculate omega? We know that omega is 2 pi f, and when we put the value of f and solve it, so omega will be 377 radian per second. So by putting value of omega, we will get the value of instantaneous current, that is it is 12 sin 377 into t. So this is the answer of the part first. And for part second, find the value of current after 1/360 second. We have to find, we know that this current is increasing sinusoidally like this, right? So we have to find, this is your small I instantaneous value, this is your peak value, that is Im. So we have to find what will be the value of I at time t is equal to 1/360 second. 1/360 second. Then what we will do? We will put value of time in this equation, right? 12 sin 377 and value of time is 1/360. and then we find out the value of this. So this you have to note that it should be in radian. It is in radian per second, radian. This angle will be taken in radian, means mod of calculator will be in radian. You have to, before calculating the value of this, you have to put the mod of calculator in radians, then only you will get the correct answer. Mod of the mod of the calculator in radian, then only you will get the correct answer. And when you calculate this, so you will get value of I as 10.39 ampere. So this is the answer of the second part. Now the third part is time taken to reach 9.6 ampere for the first time. How to calculate this time? So we have value of I is 9.6 and we have to find out t. So for this also we will use this general equation we have calculated, and we have calculated this equation as I is equal to 12 sin. So we will use this equation. So from here put value of I as 9.6 and this is 12 sin 377 t, right? And from here you have to calculate value of t. For this, you know, you have to simplify this and take inverse of this, and by taking inverse of this you will find t is equal to 2.45 into 10 to the power minus 3 second. So here again you must be cautious that mod of the calculator should be in radian while taking the inverse of this sign. So how you can calculate the value of time taken to reach current to 9.6 ampere for the first time. Now another question, the second example is calculate RMS value, average value, form factor, peak factor of a periodic current having following values for equal intervals changing suddenly from one value to next value as 0, 2, 4, 6, 8, 10 and so on. These values are written on the board and it is changing continuously at equal intervals of time. At equal intervals of time, values of current is given like this. So how to calculate this average value and RMS value? For this, as we have discussed, we will use here the graphical method. Why we will use graphical method? Because the value of voltage or current is given or known or constant in particular interval of time. Equal interval of time, small intervals of time, the value of AC quantity is constant as given here. So what we will do, we will plot this AC quantity with respect to time, and you can see here there are 10 intervals and we will plot this AC quantity. Suppose it is I or current. Equal intervals are this is current I and values are equal intervals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and so on. This is the time axis. This is time axis. Values are 2, 4, 6, 8, 10. Suppose in the first interval value is 0. In the second interval the value is 2. second interval value is 2, which is constant. In the third interval value is 4, which is also constant, and in the fourth interval it is 6, and in the fifth interval it is 8, and in the sixth interval it is 10, and again after 10 it is decreasing. In the next interval it is again 8, and after that it is 6, it is 6, ten, 8, then 6, and then it is 4, and then it is 2. It is 2. This is not here. It is 2, and then again 2. Then it is 0. It is 0, and again minus 2, minus 4, minus 6, minus 8, and minus 10, and this pattern is repetitive. This exactly, suppose this is the positive half cycle of the AC quantity, this will be the negative half cycle of the AC quantity. So we will find out the average and RMS value of this AC quantity. How to calculate? We will use, naturally in this interval value is constant, in this interval value is constant, so we will use graphical method. Graphical method. And what the graphical method says, average value of current, average value, it is sum of the values in different intervals and number of intervals. So this value is 0, this is 2, this is 4, 6, 8, 10, and so on, 8, 6, 4, 2, 0. So what will be the average value? It is 0 plus 2 plus 4 plus 6 plus 8 plus 10 plus 8 plus 6 plus 4 plus 2. So we have considered from here, and where value was 0, and again after 2 value is 0. So we can say the first half cycle is, this is your half cycle, or you can say T by 2, time period by 2. So we will find average value of this interval, and similarly RMS value. So number of intervals are 10. So when we find out the numerical value, it will be 5 ampere. So this is the average value, average value. Now the RMS value, RMS value of this current, we know that it is, RMS means root mean squared, means under root of mean of squared values, under root of mean of squared value, means 0 का स्क्वायर, 2 का स्क्वायर, 4 का स्क्वायर, 6 का स्क्वायर, 8 का स्क्वायर, 10 का स्क्वायर, प्लस 8 का स्क्वायर, 6 का स्क्वायर, 4 का स्क्वायर, प्लस 2 का स्क्वायर अपॉन 10. So this is under root of mean of squared value. This is meaning of RMS value. While explaining meaning of RMS value, we have explained like this. So this is how to calculate RMS value. Now you find out the numerical value of this. It will be 5.83 ampere. Now you can calculate the form factor and peak factor. Form factor, you know, form factor is denoted as Kf, and it is ratio of RMS value to average value. So form factor, it is Kf, form factor is Kf, it is VRMS upon V average, VRMS upon V average, and its value, when you put values, it will be KF will be 1.166. So this is the value of right. So this is value of form factor. Similarly, you can calculate peak factor, and peak factor is denoted as Kp, and peak factor is defined as RMS value, VRMS or current. If it is current, then it is IRMS upon Vm, and we have calculated VRMS. So put value of VRMS and divide it by VRMS is, it is peak factor, it is ratio of, it is ratio of peak value to RMS value. It is ratio of peak value to RMS value. So we will correct this. Peak value means Vm upon RMS value, and when you what is the peak value? Peak value of this sinus AC quantity, it is 10. So it is 10 by RMS value, it is 5.83. When you simplify Kp, you will get 1.71. So this is how you can calculate the average value, RMS value, form factor and peak factor of an AC quantity whose values are constant in a given small interval of time. So this is how we can calculate the value of AC such waveforms. Now the next example, we have to calculate the average value, effective value, form factor of the output waveform of an half wave rectifier. How to calculate this and which method we should apply? We have gone through two methods. One was your graphical method and other is your analytical method. So which method we should apply? Here the value of the AC quantity in a small interval of time, it is not known, right? Its peak value is given and intervals are given. So how to calculate which method we should use? We will use the analytical method. So solution of this, so we will naturally use here analytical method, not the graphical method. Or according to analytical method, how to calculate the average value? So average value, V average, it is area under the curve upon length of the base, or area under the curve upon time period. So from looking into the waveform, we can see what will be the time period. First we have to decide what is the time period. So we can see that this waveform is moving like this, and here it is 0, and again it is repeating the same pattern, and again it is 0, and it is going on. So what does it means? Time period is this much. This is the time period, and time period, it is t is equal to 2 pi. So this thing we have to be careful. Here it is time period is 2 pi, or length of the base is 2 pi. So average value, area under the curve, upon length of the base, oblique time period. We have to be careful, time period. Now area under the curve, we will find area of this, and this area, it is 0. So first part we can write, it is, what is the waveform? This is the, what is the equation of this? Equation for this, it is small v is equal to peak value, that is Vm sine of omega t, or we can say sine of theta. So this is the equation of this, and by equation of this we can find out the area. So what will be the area? Area will be 0 to pi and Vm sine theta d theta. This is the area, because second part is 0 to pi, you can write pi to 2 pi, it is 0 d theta, and length of the base it is 2 pi. When you will simplify this integral, you will find value of the average as VO peak value upon 2 pi. So this is V average. Now how to calculate RMS value of this AC quantity, such type of waveform? How to calculate RMS value of such type of waveform? So this is VRMS, and this will be area under the squared curve. RMS root mean square. It means under root of mean of squared value. We have to be very careful while calculating. It is under root of mean of squared value. So while finding the area under the curve, we have to find area under the squared curve. We have to be very careful. Area under the squared curve. Your curve is Vm sin theta. It means squared curve is V square is equal to Vm square sin square theta. So this is the squared curve upon length of the base, या time period, length of the base. And here you can say that so this means VRMS we can write is equal to area under the squared curve, area under the square curve 0 to pi VU का square sin square theta d theta. First part is this one, and second part pi to 2 pi. It will be 0 square d theta. 0 square is 0 upon length of the base, that is 2 pi, and whole is under root. You have to be very careful. It is area under the squared curve. Root mean squared means under root of mean of squared value. So this is how we calculate VRMS, and when you simplify this integration, you will get VRMS is equal to VO by 2. So now we have got the VRMS also. Hence we can calculate, in this question it was to find out V average, VRMS and form factor. We know form factor, it is ratio of VRMS to V average, VRMS to V average. And when we calculate this, so we will find VRMS is VO by 2 and V average is VO by pi. So hence its value will be 1.57. So this is how we calculate the RMS value, average value, form factor, peak factor, etc. of a sinusoidal type of waveform. And here in the particular case, the sinusoidal waveform was output of a half wave rectifier. Now the next question we will discuss the output of a full wave rectifier. This is the output of a full wave rectifier. We have to find out RMS value, average value, form factor of the voltage waveform shown below or you can say this is output of a full wave rectifier, right? How to solve this? Again, we will use the same analytical method. We have to be careful when values of the AC quantity in small intervals is not fixed, very small intervals, the value of AC quantity is not fixed, then we will use the analytical method. And according to analytical method, we will find out what will be the value of the average value. Average value we will average value, RMS value we can find out, right? So suppose we want to find out RMS value first of all. What will be the RMS value, and how to calculate RMS value? First we have to see what is the equation of this AC quantity. Again we can see that it is a sinusoidal. Sinusoidal means its equation is, since it is voltage, so voltage is small v, and its peak value it is 100. So it is 100 sin theta. It is 100 sin theta. So you can say its square value v square, it means 100 square sin square theta. Squared value is this much. So suppose we want to find out RMS value, Vrms, and to calculate Vrms, we have to first find out equation of this AC quantity, then we have to decide what is the time period of this or length of the base. Time period, we can say this AC quantity is varying like this. It means it is repeating its pattern after each pi, each interval of pi radians. So you can see that this is the time period. So this is your time period is pi here. Time period is pi here. Our length of the base we will take as pi, since it is repeating the pattern after every pi radian. So how to calculate Vrms? It is area under the squared curve, area under squared curve over a cycle upon length of the base, या time period, and whole under root, since it is Vrms. Now area under the square curve means integral 0 to pi 100 square sin square theta d theta upon pi and whole under root. So this is how we have to calculate this RMS value, and we now use this integration. We know sin square theta is 1 minus 2 cos theta, and we can integrate cos 2 theta very easily. So we use the simple integration method, we integrate it, and by simplifying we will get Vrms is equal to 70.71. This is your Vrms. Now we will calculate V average of this, So we can say V average, it will be area under the curve, means area under the curve, it is integral 0 to pi and 100 sin theta d theta upon length of the base, that is pi. Integrate this and simplify, you will get the value of this average voltage, it is 200 volt. It is 200 volt. Now we have with our RMS value, we have our average value. So we can easily calculate the form factor, and we know that form factor, it is, our form factor is VRMS upon V average, and its value when you simplify it will be 1.11. So this is how we calculate average value, RMS value of a sine wave, and which may be output of a half wave rectifier or output of a full wave rectifier. And so we have discussed here examples related to both the methods of calculating average and RMS values of the various types of waveforms. Various types of waveform means when in the waveform the value of the AC quantity is constant during very small equal intervals of time, and when the value of the AC quantity is unknown between or during very small intervals of time. That is in case of half wave rectifier output or full wave rectifier output. So this is all for today. Thank you.